see the screen?
Yes, sir.
Okay, do you have any questions from the last class? Well, we are talking about dynamic binding, or in more general case, it is functional binding. Function binding. And function binding, we are more familiar with static binding, which is the default binding process. And binding is a process where a function call is replaced by the actual specification of the body of the function which need to be triggered. So the whenever we write a function call, like in the main, if we write here fn, and if say fn has got two copies, one is fn void and fn int. So if we write here fn5, then it means it is a call to this function. So if these are stored in the stack segment, the code segment, the object code or this function bodies, all these are stored in the code segment. So there will be some location, or we know that the function pointers are there. So function pointers can store the address of a function. So in this case, whenever fn5 is called, so the address of this function in the code segment, say if this is 3010, so it will write call or jump to the location 3010. Okay, so jump to this location. So depending on the assembly level language or machine code, such kind of things will appear here. So this will appear instead of this during the compilation process. And if we have got a function call with void arguments, then it will have replaced it as if it is jumping to, say, maybe 1050. So it is 1050. So it will jump to this one and it will jump to this one. So this part, this is done during compilation. Or this is in some sense static. And in C there is no ambiguity. All functions, they have the unique name and all. So whenever you call a function, you specify that which body to call, and the compiler simply replaces it during the compilation process. Even when there is function overloading, we know that there is no ambiguity. The ambiguity is resolved during the compilation. So this is still static binding. So static binding, here the function definition, the default function binding is performed during the compilation time, and the normal function calls, overloaded function calls, overloaded operator calls, these are all following the static binding. In contrast to it, we started talking about dynamic binding, and this is in some sense dynamic means whenever you call a function in the main or in some other function body during the compilation process, such replacement of this function name cannot be done. So this need to be deferred for some later time. So after compilation we start execution. So this is during execution only that the function body can be resolved, I mean which function body to jump. So that's why in that sense static binding is often called as early binding, and dynamic binding is often called as late binding. It is late in the sense after compilation during the execution, and it is early in the sense it is during the compilation phase. Okay, and the examples of such things are virtual functions that we already explained, or we found that when it is essential, and writing the keyword virtual by using the keyword virtual, we can tag it. So when we deal with hierarchy of classes, inheritance, then if a base class pointer or reference, if a base class pointer or reference are assigned the address or the reference of some derived class object which is down the hierarchy, then that is allowed, that is called upcasting. And in that case, if using the base class pointer or reference some methods of the derived class is invoked, which is common to the base and the derived class, in that case, if I tag the member function as virtual in the base class, then it can have an intelligent invocation depending on which type of object, base or derived, it is pointing towards. It can invoke that copy of the member function. So that is done in the runtime, and that is called dynamic binding. So another example of dynamic binding is the function pointers. So this we discussed in some of our previous class. So in this class I'll just review these two once again, and I'll focus on this use of dynamic virtual function in a multi-class hierarchy. So in my last class I talked about two class hierarchy. There was a base class, there was a derived class. And if we have multiple classes like a base class, a derived class, then another derived class. So I'll just see the syntax and see the use of the virtual keyword in that case. That is one objective of this class, and another one will be to see whether we need destructors to be declared as virtual. So that will be the focus of today's class. And after that, maybe in the next class we'll be talking about how this feature of dynamic binding gets actually implemented internally using the concept of vtable, virtual table, and virtual pointers. Okay. So let us focus on this piece of code. This is a very trivial one, and we have already discussed about it. So the objective is to show how the example of dynamic binding that is achieved using function pointers. Can you see this code? Hello?
Yes, sir. Yes, sir.
Okay. So as you can see, there are two functions. One is the sum and the sub. It has got the same prototype or the interface. Int, it takes two ints and returns one int. But the body of the functions, one performs addition, one performs subtraction. So if there are multiple functions with the same prototype, probably we can declare a function pointer, something like this. So this is the function pointer. So this is as fp1 is a function pointer because of this, which is capable of pointing to any functions which accepts two integer arguments and returns one integer argument. So in fact this prototype matches this prototype of this function pointer, whatever it can point to matches with the two examples of these two functions. That means this fp1, which is a pointer variable, function pointer variable, can sometimes point to sub, the address of this function sub, or the address of this function sum. শুভজিৎ আমি ক্লাসে আছি, পরে কথা বলছি। হ্যাঁ পরে বলছি। Okay, so fp1 is capable of pointing to sum, capable of pointing to sub. At this point we have I have assigned the address of sum, this function, to this function pointer. So before that I have just called this sum, the function, and the sub, and then here I am assigning this, and using this pointer, so I write an asterisk, that means it takes me to that function body, and then I pass these two arguments. So using this function pointer I am invoking the function whatever this fp1 is pointing to. And then at this point I am assigning the address of sub to this function pointer. So the function pointer points to sum at this point and invokes. Then at this point, because it's a variable, it can point to sub, and then it invokes that sub function with suitable arguments. And here I am declaring another function pointer fp2. Okay, so this is another function pointer that I have declared. Here I am accepting an integer value with value 0 and 1, and I say that if the value is 1, then this fp2, this function pointer, is assigned the value it will be pointing to this variable sum. If it is some other value that I enter, then this fp2 will point to sub. So it's a kind of choice. Dynamically I can choose to whom to point to. Okay, so and then whatever it points to based on my choice, I just invoke that particular function. So the code is pretty simple. Now the thing is, we'll try to identify which of these calls will be treated as static binding and which will be treated as dynamic binding. Okay, so at this point, what will be the binding here? When I just call sum 56 or sub 86, hello, don't take too much of time, because there are other topics also that I would like to discuss, and I should know that, okay, whether you are getting me or not. So please try to respond. So what are these? What type of binding will take place here? These two places.
So dynamic.
Hello? Are you getting me? Can you hear me? Hello?
Yes, sir. We can hear you.
So please respond. Otherwise, it seems that the connection is lost or something like that. So in the first two cases, what will be the case? Static or dynamic?
Static.
It will be static because it is simple one. So let us say that I denote it, the static binding, I denote it with the green one. So this will be bound to this, sorry, this will be bound to this function body, and this will be bound to this function body. Now at this point this fp1 is pointing to sum. So what will be the call here, static or dynamic at this point? Or in other words, can the compiler with certainty bind the function to that call, function body to the call? Hello?
Yes, sir, it can.
Because the compiler knows it, because you have hard coded this, you have assigned sum to f1, so there is no ambiguity. So if there is no ambiguity, the compiler will again bind it. So this will be again pointing to this sum. Same goes here also. This is for sure the compiler will know, and it will point to this one. So these solid lines means you can expect that it will have something like jump to this location, jump, so it can do it. But this fp2, when I declare this, I am not assigning any value here, right? So this is not initialized or assigned any values. I am assigning value to fp2 depending on my choice of value of x. So what will be the value of x? Can the compiler determine during compilation? It is not possible. So whether this fp2 will be getting the value of will be getting the address of sum or the sub, can it be known during the compilation time?
No, sir.
So during compilation, can we know which function this fp2 will point?
No, sir.
Hello?
No, we can't know during compilation.
Bit louder.
So we can't know during compilation.
So if this is not known, so at this point there is a function call, as you can see, using the function pointer there is a function solve. So this binding can it be done during compilation time as it was done here? Can we definitely bind it? Can we draw an arrow from this point to either sum or sub during the compilation? Can we bind? Binding means can we draw an arrow that it will be calling sum or sub at this level? Is it possible? So right, so this is not possible. So binding cannot be done during compilation. Are you convinced about that?
Yes, sir.
So as you can see here, so everything seems to be same. So the code, just looking into the code, you cannot figure out what went wrong, but only looking into this piece of code that is prior to this. So you see the calling pattern is again the same. It's the same way it is calling here, here, here. But because of this piece of code, the compiler knows that I cannot bind it. So I don't have sufficient information because this assignment is based on X. So this is a part of the compiler that it does. So it will defer this binding and it will be deferring it for the time being. That's why it is called late binding. So this is late binding. And how this is achieved internally, that's a different question. But as you can feel that this is an example of late binding, right? So even without using the keyword virtual, there can be instances in the code where we may need to go for dynamic binding. This is one example. So this gives more flexibility in your code, and we can have nice examples using this also. But the one that we so these function pointers, we know this is one way of one feature, one such example where dynamic binding are often say found, and there is another example is a virtual function. So this we already have discussed. So this is a simple code where just one more example. This is a simple code where we have got a base class instrument, right? And say there is another derived class which is say guitar class, because you know guitar is an instrument, then piano is an instrument, then maybe the other musical instrument. So instrument is a general instrument class and guitar is a specialized instrument. So it has got a easier relationship between these two. And we have just one method interface that is called play. So again, it's a dummy method interface. So let us assume that it is. So play is the method which is defined in the instrument, and because of inheritance, public inheritance, because we are all focusing on public mode of inheritance, so this play gets inherited here. But say for example guitar, in the guitar class, it wants to override the definition of the method play, which is defined also in the base class. So here it says that maybe instrument play, it will be having some kind of message like this. So because these are dummy classes and this is guitar play, so that we can distinguish that which copy is getting invoked. Okay, so that's all. And there is one more feature that I've used. In fact, last year I taught enumerated data types, enum, which actually so how many of you are aware of enum, enumerated data types, in C++? Anybody who knows the use of it? Hello, are you aware of this enumerated data type? Anybody?
No, sir.
So generally this is enumerated data type is defined. Sometimes you see uh, say weeks of a day, how many weeks are there? Say 7 weeks, sorry, 7 days in a week. So in that case I can say that there are 7 days in a week, and maybe 0, 1, 2, 3, 4, 5, 6, 4, 5, 6 and 7, 6. So there are total 7. Now Now how to specify those day of the week? Say I know that 1, if it is 1 means it is, say it starts from Sunday. So if it is 1 it is Monday, if it is 2 it is Tuesday, Thursday, Wednesday, like this. Now if you look into the case like for days of a week, so maybe that I would like to create a data type called days of week. Days of week. That's a data type I would like to create. Now the days of week, in this case, it will comprise of 6 integers, right? So in the entire integer range, which is basically plus infinity to minus infinity, it has got, I mean, it's not actually infinite, but it's a very long range of integers that it encompasses. I would like to choose only a small part of it to be a representative of this data type. So day of weeks, if I write here, say it is D, so D should be an object which I would like to restrict to only these values of the integer range, right? So it starts from 0, 1, 2, 3 up to 6. So if I would like to do like this, so I would like to probably create a new data type which is a subset of the entire integer as days of week. And then there is an object. So if I assign D to some values like 8 or 9, it will not allow like that. Okay. So here if I write it, so these are data type, and how I define its range, I can define its range like this. Say Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, so if I just write like this, that means the compiler knows that these days of week is a new data type, or it's an enumerated data type, and D is an object of it. And this enumerated data type means you are trying to enumerate this finite set of, say, options in this particular range. So this by default, if you don't specify anything, Sunday will be treated as 0, this is 1, this is 2, this is 3, this automatically gets the values, right? So if you write here, say if you assign D equals to Monday, and if you write cout D, it will display 1. Okay, so that is what it means. You can consider AM PM also like this, AM PM. Okay, so time of the day, T of day can be another data type. So X, it is like this. So this AM will be 0, PM will be 1, like this. So the another objective is, so this instead of 0, 1, 2, 3, it can be associated with these symbolic values like this Sunday, Monday, and all this. So you can use that. You can assign D equals to 1 also. You can assign D equals to Monday also. So that way it works. So in general, the purpose of this enumerated data type is to assign a finite range of integers to a set of symbols which will be more readable, and you can use that finite set as a new enumerated data type where it works. So like Boolean is not supported by our C++ compilers, many of the C++ compilers. So you can create bool or Boolean, and you can write here, say enum bool, and you can specify here like this, true, and so 0 is false, and this is true. So once this is done, then when I write Boolean, say x1, then x1 can take either 0 or 1. So this false is 0 and true is 1, like this. So this Boolean becomes a new data type, and it can only take 0 and 1 values because that is how we have defined it. Is that clear? So I mean, syntactically you should write this enum when you are defining this enumerated data type, enum enumerated data type days of week, and it will include these few finite domain of values, and then you can create days of week, this object, and you can assign values and you can play with the value. So this is not related to the discussion that we are making, but this is just a feature that I have used, and it is sometimes often used in C++. So is this part clear? And it's not a big deal, but is that clear? The use of enumerated data type. Are you getting some idea of it?
Yes, sir.
Any question on this? Hello? Is that fine, or do you have any questions on this? Hello? Can you listen me? Can you hear me?
Yes, sir.
Please respond. Otherwise, sometimes it seems that the connection is off. The network connection has gone. So here in this case, you see that we have defined track. We play different tracks, enum track ABC. So this means ABC can be anything. We can use any symbols. So A is 0, B is 1, and C is 2, like this. Now this is the base class instrument. It has got play as a method, which just displays instrument play, and then guitar class is basically derived from the publicly from the instrument class, and it has overridden the method play, and it displays here guitar play. Now these are global functions. You see these two functions, this color tune and this color tune and guitar tune, these are global functions. Just try to focus on that what they are doing. So in the color tune we are passing, or the first argument is a instrument pointer. It's a pointer to the base class, right? Instrument is a base class. So it's a pointer to a base class, and here you are passing some track. So if you pass 0, 1 or 2, or maybe ABC, it will work. Okay, so what it is calling, so whatever track you have passed, it will invoke through this this pointer, it will invoke the play method passing the argument of R. Okay. And in the guitar tune, guitar is a derived class. So in the guitar tune, it has defined a derived class pointer. This T is a derived class pointer, P is a base class pointer, and both of these are accepting a particular track in the second argument, and both doing the same. Here P invokes play, and via T it invokes play, passing the R. Is that okay? Is that clear? The code. Hello?
Yes, sir.
Is this part of the code clear?
Yes, sir.
Okay. So now let us see that so what I have done, I have declared a base object, I have declared a derived object. So if I call s.play and g.play, s.play means s is a base object, through that I invoke play. So what do you think? Will the compiler be able to know or resolve the binding issue here while it calls s.play and g.play? Will binding be an issue? I mean, resolving the binding, will it be a problem here while these two are invoked using the directly the object, base and derived object? Can the compiler resolve it?
Yes, sir.
So s dot play, s means it's a base object. Base object invokes the play means it will be the base play. That's all with the value a. A means actually it is passing the value 0. Okay, because ABC represents 0, 1, 2. And G dot plays. So this is basically static binding. Static binding means you can think of that there's a direct say jump. You are sure that you will be jumping there, no matter, I mean, as many times as you compile it. So it will always be jumping, and G dot play you always be jumping to this one. Now you have caller tune S. So I am calling this global function caller tune. So this is what it is in the first argument. What it is a base pointer, right? It's a base pointer. So if it is a base pointer, what I am passing here, well, I am passing the address of S, that is a base object's address, comma B. So first of all, will this be allowed? That in the base pointer you are passing that base object's address. So this is trivial because you are passing the same type of object's address. So if I write caller tune ampersand s b, this will be allowed. This passing will be allowed. Now, will this call, I mean, internally here when it comes here, p dot pro play, and if I consider the second caller tune, I mean the second call to the caller tune function with the address of g, which is the derived object's address. So first of all, will this be allowed? The second one also will be allowed, passing the address of g. Caller tune is having a base pointer. In the first call I am trying to pass the base object's address. In the second call I am trying to pass the derived object's address. So will both of these be allowed?
Yes, sir.
Hello? So the first thing is trivial, but the second thing is an example of upcasting. So this is also allowed. Now the question is, now in both the cases when it calls internally this p arrow play, so which play it will be triggering? That means via this base pointer you are trying to invoke the play method. So can you figure out that which play will be triggered in both the calls?
Base classes.
Hello, are you getting me or not?
Yes, sir, we are getting.
So within this caller tune, so first of all, both of these calls to the caller tune are allowed. Now once it is inside the caller tune, this p arrow play. So I'm talking about this p arrow play. So this p arrow play, which copy of play, this play or this play, which play will be invoked? Can the compiler know for sure?
Sir, in both cases, I think base classes play will be invoked.
Yes. So okay, this has been just removed. So this will be this one. Okay, so at this point when this calls play, so this will be for sure because it is a base pointer. So now it is that same example. The PA is not intelligent enough because you have not used the keyword virtual. So in this case, this play will surely be triggering this base copy of the method in both the cases, you see. So that's why in this call, say this is this, but in this call where you have got, so this calls instrument and this also calls instruments. Okay, this means even though you have passed the base pointer, the derived class's address, derived object's address, but still this play will invoke the base method copy. So although the upcasting is allowed, but still the binding is static. Is that part clear? So that is what it happens here. Now if I call guitar tune, you see guitar tune, I am calling the guitar tune also. I mean this that means this particular global function I am calling. Again, I am trying to call it by passing the base object's address and passing the derived object's address. It is ampersand s ampersand g. Okay. So first let us see whether this call is allowed. So the first case, and what is guitar tune? Guitar tune is, this is a derived pointer. So the derived pointer, I'm trying to pass what? I'm trying to assign there the base object's address. Is that allowed? Base object's address, can it be assigned to a derived pointer?
No,
No,
sir.
sir.
This is not allowed. So downcasting explicitly is not allowed. If you force it by forceful typecasting, that might not be recommended. I mean, that is dangerous. So downcasting is, so this call will not be allowed. You cannot simply compile it. But the second one is allowed, because second one is trivial. A derived object's address is assigned to a derived pointer. So if you do this, it will be simply triggering guitar. And in case it is trivial to note that this play will be referring to this particular copy. Okay. So the point is, in this case, everything is static. There are examples of upcasting. Upcasting is there here in this case, in the second case, but all the functions that are bound were bound, or the function bodies are bound all in the compile time. And even though there was something that we are expecting, but it was not implemented. So how to, so what we didn't expect is that when this caller tune is called using the derived object's address, we would expect, probably we would expect that instead of instrument play, it should have played, it should have executed this copy of play and should have displayed guitar.play, guitar scope resolution play. So that is not happening. And we also noted that to make it possible, we have to tag that particular method which we want to make, want to have executed in a dynamic fashion or dynamic binding. We should be tagging it as virtual. Okay, so if you do it as virtual, make it as virtual, so this virtual keyword actually gets inherited here also. Okay, so this also becomes virtual even though you don't do it. And because it is now made virtual, then if I write the same piece of code just by adding this keyword virtual here, then these two, this play and play, these are again trivial to note that this will be static. So this is static, this is also static. This caller tune, this is trivial, this is again sorry, I mean this caller tune, when it is calls these two, so both upcasting. Now when it comes to invocation of play within the caller tune, now you see you are accepting both upcasting and the normal case, but because this play method is tagged as virtual in the base class, so this call will not be bound in the compile time. Rather, it can be either this or it can be this. So this or this. So this means this, there is some kind of dynamicity, and that is possible because I have used the keyword virtual. So here you cannot expect a direct call to the function body with some address in the compile time. And what about this one here? What about this one here? This T arrow play, will it be dynamic or static binding? Are you getting me? So dotted means, let us assume that I represent dotted as dynamic binding and solid as static binding. So what about this play? Will it be Will it go for dynamic binding or static binding? The T arrow play?
Dynamic.
It will also be dynamic. Why it will be dynamic? Why it will be dynamic? I mean, what do you think? Why do you think it will be dynamic? Is it pointing to any of the classes derived from that? The guitar, there is no other classes here. So will it still be dynamic? What do you think? Are you getting my question? Your answer is correct, but my question is, why do you think that it will be dynamic?
Because sir, it's virtual.
Yes, a bit louder.
It's virtual, I guess, sir.
Yes,
Virtual.
because it is, you see, in any case, this play is table tagged as virtual. Even though you don't write it explicitly, it has inherited the keyword also. It is not only this method which you have overridden, but it has inherited the virtual keyword. And because up to its level, because you might have later on, you might have added some more, derived classes below this guitar, maybe electric guitar, some other kind of guitar, like that. So if that happens, so then, so no matter whether you have done it or not, but this, even at this level, because it is virtual, so whenever this is called via this guitar pointer, via this derived class pointer, because within its level it is virtual, it will treat this particular call to be virtual, I mean to be dynamic. Okay, so this will call to this, but this will be a kind of dynamic one. So I can write it as in terms of dotted notation. In this case, this is only one option, but if you have more derived classes, you will have multiple other options also. Is that part clear to all of you? Is that okay?
Yes, sir.
Okay. So this holds true. You see, the previous example is with object pointers, right? So the same thing we have done, I have done with object references. So what is the references? It's like, instead of, you see, just focus on this underlined ones. So instead of a pointer, I have defined a base reference. I have defined a derived reference. And because it's a reference, I can just write play.p or t.p instead of play arrow p, t arrow p. That's all. So the whole stuff remains the same. And here also the same thing. So which one to call? Which one to call? Can it be determined statically or dynamically? So because there is no use of virtual keyword, so everything is dynamic here, right? But once you tag this as virtual, then this gets inherited also, this gets virtual. So automatically the call to this play and the call to this play both becomes dynamic. Sorry, I mean, this should be, that was a mistake that I made. This should be tagged as dynamic. Okay, so this should be also, so in this case it is not revealed, the dynamicity is not revealed, but it will be actually dynamic, and the compiler will not resolve it. Okay, so this holds true both for pointers as well as references. So the same logic holds. Is that fine?
Yes,
So
sir.
now, with respect to the previous example means in the last class we talked about this example. There is a class B, there is a class D which is derived out of it, and it has got Fn, it has got Gn, and it has got Fn, Gn, and Hn. Can you recall? So this Hn has been added to it, and now we are trying to use the reference and the pointer to the base class, and using that I am trying to invoke the methods of the derived class. So if there is no virtual, so although there is upcasting that is felt, but the binding is all static. But once this once this virtual keyword is given, then upcasting as well as dynamic binding takes place. So instead of invoking the base classes copy when we use the base pointer or the base reference, instead of invoking the base copy, it invokes the derived objects copy, and that is what we wanted. So I think the example that or we have got sufficient examples where we show that dynamic binding, late binding, or runtime binding is a quite useful feature, and it can be noticed when you use function pointers. Not always, but there are cases where you can write the code where the binding will be forced to be dynamic, the one that we have shown. And also, when you are dealing with hierarchy of classes, inheritance, there are cases where when you override the same method that was defined in the base class, it is always better to tag the method as virtual, so that if it is overridden in the derived classes that follows, during upcasting you can have the actual invocation of the method depending on the object type. Okay, so we know the use of dynamic binding and also what the feature is. So this is just to summarize. I am not going through these lines. I think these are all explained. Just focus on the last part. So for virtual functions, dynamic binding takes place. So whenever you tag a function as virtual, this is surely going to be a dynamic binding example. The function call with appropriate function body, this is what binding means. Okay, depending on, so in this case it depends on the binding depends on the type of the base or the type of the object it points to. Is it a base object or derived object? So this is based on the type of the object pointed or referred to at that point of time. So at that point of means it might change often, but at that point of time whatever it's pointing to, it will consider that. So in this previous example, as you can see that at this point it is pointing to, when we are calling this, it is pointing to the base object. At this point it is pointing to the derived object. So particularly at that point, whatever it points to, it will be invoking that copy. And this is sometimes better known as this dynamic dispatch. That is also a technical term. So this facilitates dynamic dispatch. Okay, so we encountered two relevant terms. One is virtual function, dynamic binding, and also dynamic dispatch. And we can say that dynamic binding facilitates dynamic dispatch. So let us consider one more like relevant example related to this inheritance and all this. So I think up to this there is no problems, right? So can you focus on this particular code, what it shows? It's all the same. We have got B and we have got D, the derived class. It has got fn and gn, these two functions methods, and fn and gn gets inherited and this hn gets added. But the thing is, fn gets modified also, gn gets inherited, fn gets inherited but also modified, and hn is just added to it. So up to that it is fine. And the thing is, we have tagged it as virtual, so that is not a problem. So that means I know that fn, because it is it might happen that fn gets modified in the lower or in the derived classes, so there might be a choice. So I have tagged this as virtual. Okay, but gn, as you can see here, gn it just gets inherited without any modification of the code. So that's why we may not tag GN as virtual. We may not, as per the design. Okay. So because Fn gets modified, we have tagged it as virtual. Because Gn just gets inherited without any modification, we may leave Gn as it is. But Hn is just a newly defined one. So now just focus on these calls. I have created an object of type D, that's a derived type object, and I'm trying to call d.fn, d.gn, d.hn. So all these will work, right?
Yes, sir.
So here, will it be static binding or dynamic binding? Or in other words, will the compiler resolve when it compiles? The call to
Static binding.
hello? Will it or can it resolve while dn calls fn, gn and hn?
Yes, sir.
See, the problem is if you have got a specific object given, so there is no ambiguity. So the ambiguity arises if you are dealing with a base pointer, then there is a possibility of ambiguity, and only then there is a question of dynamic binding. But in this case, although you see fn is a virtual function, doesn't really matter, because this virtual function is invoked directly by a derived object or maybe a base object. So if this happens, although it is capable of having the dynamic binding facility, but this is not required here. So the compiler will simply go for static binding. Is that part clear? So just having a virtual function call does not mean dynamic binding is required. So it is required whenever those situations occur, the one that we have shown while calling the through the global function caller tune and all this. Now what about this call d.fn? Now can you see the difference between these two fn? Can you see the difference between these two fn? This base copy of fn and this derived copy of fn? What is the difference?
Arguments.
Hmm?
Arguments,
It is
sir.
so the thing is, it is not only overridden, you see, it is not only overridden but also overloaded. We know what is the meaning of between overloading and over. Okay. So this is not only overridden but also overloaded. Overloaded means the copy that it inherits is void type, void argument. But I say that I am overloading it because I am trying to create another copy of fn which accepts integer, which is different from fn, right? Now the interesting thing is, if I call d.fn, do you expect, because d.fn means I am trying to invoke through this derived object the copy of the fn which has been defined in the base class, which is distinct, right? Because fn4 I know it is this, but fn void, it should have invoked this fn defined in the base class. Are you getting the point? So will it work? Will this invocation work? As it shows in red, there will be error message and it says that no matching function for call to d::fn. First of all, have you got the issue? Hello?
Yes, sir.
So if it is simple overridden, then you are trying to update the body of the function, but the interface remains the same. So then you know that if you tag is a virtual, that will work fine. But now I say that no matter what it is virtual or not, but the thing is the base copy is not only overridden but overloaded. You just create a different interface for that. Now therefore in the base class, in this base class, in the derived class, I can think of that having fn int and also fn void. So both exist in the derived class, right? Now can this derived class invoke this void, the member of that fn void defined in the base class? If you compile, you will find that it is not showing. I mean, you cannot access that. Now my question is, what we need to do, or is it possible to make it accessible? Even though I override, if I want to make it available to the derived class also, what should I need to do? That means I want this call also to work. So what changes should I make in these definitions? Is my question clear? Any idea? In other words, I would like to unhiding the overloaded base function. Once you overload, the other copy which is in the base class gets hidden. So can I unhide it? Is the question clear? Do you have any answer? Hello?
The question is clear, but
Yes,
I'm
a
not
bit louder.
having any
Bit
idea.
louder.
The question is clear, but I'm not having any idea how
Okay,
to
so
solve.
this is the answer. Can you see? Just focus on this part. What I mentioned, using, we are just utilizing the keyword using b:(fn). What is the purpose? Its purpose is to unhide a base version. Is that clear? So you're not changing or doing anything. So the thing is, once you override, and not only overload it, it will mask all the other versions that you, all the other, say, overloaded copies that you have defined in the base classes. So if you would like to reveal that, if you would like to unmask or unhide that, you can just do it specifically by tagging them as using. So using means you are allowing this to be used. Which one? The base function, the function fn corresponding to the base class. Once you do this, now this works. And when it works, definitely it will be giving b:(fn), right? So using keyword, we can unhide the base version too in such cases when you have got this kind of conflict. Is that part clear?
Sir, why did you change the argument type in the derived class, sir, for D?
No, I mean, sometimes it may be needed. That is the point. Sometimes it may be needed that you not only inherit, say, as I mentioned. So what are the kind of principles that you follow during inheritance? So the inheritance, you say you are inheriting the car. So inheriting the car from your father, the car was maybe say 10 or 20 years back it was purchased. So those days they were just like normal physical locks, the keys. But now when you inherit the car of your father, now you would like to have smart keys, like the remote control keys to unlock and open the doors. That you may add that feature. So when you are adding the feature, so that the interface to open the car, open the door of the car, so open the door, maybe the method that was defined in your father's class, that the car, how to open the car. So it takes a key as an argument and it opens the door. Now as his descendant, you have inherited whatever your father was having, the properties and all, and you have inherited the car. Now the car, you know that okay, this is too old feature, so I would like to have modern features, and you have added smart keys, remote control, those keys to open the car. Okay, smart locks. Now now the option is no, because it's a smart lock, so the open the door of a car, it will have a different interface. It cannot use the physical keys, it will have some smart keys. So that's a different interface. That is a reason why you define a new interface. But the question is, when you are defining the new interface, are you still allowing the car to be opened by the physical keys? Definitely you are, because I mean, it does not mean that it will not be opened. So the thing is, you want to have both the provisions. So then you unhide. But normally, if you don't do that, So once you have a smart lock, it is implied that you will not be using the physical lock anymore. But now the case is using keyword, you want to have both of the facilities. Is that clear?
Yes.
Sir, but in the function means the derived class function void, you have taken argument int, but in derived in the next case you have taken argument as the void. So
Yeah, here this is void, and then here it is int. Yes.
Sir, then in that case, the prototype is same. We need not use the using keyword.
Are you talking about this one here?
Right side, sir. Right side part.
Right
sir,
side.
function arguments are defined for the void function in the left side and right side inside
Yes, yes. No, no,
the
I understand.
class.
So you say that there is no ambiguity even without using the keyword, even without applying the using keyword, it should have worked. Is that your question?
Yes, sir. Because the prototype is same, so we
Yes,
need
but the
not
thing
use.
is, yes, but the thing is, I understand your point. So you say that if there is no ambiguity, why you are stopping this? I mean, by default, why you are stopping? But maybe, uh, maybe because of some design issues. By the default says that when you are defining and overloading a particular method in a derived class, inherited method in a derived class, the default is to mask the rest of the options which is already there in the rest of the interfaces, even though they are different in the base class. So that is how the designers have designed it. Okay, so this is a kind of feature that you have to accept, but there might be some reasons in terms of the object oriented design. So default means generally people prefer like that, so you are just trying to shield or mask that. So that is a general default one. But if you want, so you say that why don't the default is otherwise, like it should have been like the just the reverse. The generally you have both the options. If you would like to hide it, you just hide it. But the designers, they have chosen for the other option. Default, they hide it. If you want to unhide, you use a keyword using. Like your
Sir,
intuition
but
says
in
that what you
this
are doing, but that is maybe some kind of design issues that they have thought, which might be maybe explored while you are going to the details of object oriented design. It's basically purely a design issue and a design choice, not probably related to directly to the syntax of the code or the programming. Got my point?
sir, I have a question.
Yes, a bit louder.
Sir, I have a question, sir. D dot fn4 you have declared in the main function, then how it will be works? Means there is no void function which offset integer argument. So how will d dot fn4 work in the
D dot
second
fn4.
case?
This
Yes,
one,
sir.
how this will work?
Yes, sir. Because there is no void function that offsets integer arguments.
Sir, in the right side part,
Okay,
the
okay. No, no,
overloading
no.
overload
Sorry.
is not
No, no. There is a
occurring.
mistake. Sorry, there is a mistake.
The argument type should be int. No,
No, no,
that
no.
is what he's saying.
Yeah, yeah. Okay. The whole confusion is because of this. Sorry, sorry. Is this why the confusion occurred?
Yes, sir. That is the
Yes,
reason.
sir. Yes, sir. That is the
Yeah, yeah.
reason.
Sorry, I skipped that part. It was a mistake. It was a mistake. Okay. I didn't get your question. Yes. Now is it okay? Sorry.
Yes, sir. It is okay.
Is this fine?
Yes, sir.
Okay. I think it's already we are almost it is 1 hour. So instead of trying to continue with the virtual destructors, I'll take this in the next class. That will be better. We'll do it afresh, and it will not take too much time. And after that, in the next class, I'll do this virtual pointer and vptr and vtable. So that will end the discussion, and then maybe a short discussion on this uh, this debate. That will take one more class. Okay, so when will be the next class? Next class, can I have it tomorrow?
Sir, we already have a class tomorrow.
Okay, so tomorrow, I think, when is the class scheduled? From 11 to 12, no? কটা থেকে ছিল?
Yes, sir, from 11.
11. Okay, let it be from 11. If I have any change, slight bit of change, maybe I would like to prepone it a bit early. Maybe from 10:30, I'll let the CR know about it. Okay. So tomorrow I'll take the class, and then I think maybe one more class will complete this part, dynamic binding and this polymorphism. This part will be done, and the next class I'll be uh, targeting the templates in C++, writing template classes in C++. So that will have more or less the syllabus covered. And I think you are solving the assignments that are given. So by the next week, I'll be giving the assignments on the templates, using the templates. Okay. If there are any questions, you can ask. Otherwise, I will leave. Sorry for the mistake. I just skipped that. I didn't get the question. Anyway. Anything else?
No, sir.
Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.